Let us move on to the next lecture on advanced level problems on impulse, collision and center of mass. This is the 7th lecture in this series and we are only into collision now, which means there will be more lectures on this chapter in the offing. Let us hear what this lengthy problem is telling. Problem number 1 in the lecture goes like this. Two particles, 1 and 2, moving in the same direction on a smooth horizontal surface are involved in a head-on collision. The masses of the particles are m1 and m2 respectively. Their velocities before the collision are u1 and u2. The coefficient of restitution for the collision is E. In part A, derive a formula for the impulse exchange between the particles. Modify it for the limiting cases of E is equal to 1 and E is equal to 0. Hence show that the other conditions remaining the same, the impulse of an elastic collision is twice as much as that of an inelastic collision. Interesting relationship. In part B, derive a formula for the kinetic energy lost by the particles, modify it for the limiting cases. If we have done our theories on collision well, it should not pose much problem to solve this question. We have to apply somewhere the impulse momentum theorem and have to handle a number of equations in a clever way to get to the solution. Remember, the answer should be expressed in terms of the given quantities, which are the masses m1 and m2 and the initial velocities u1 and u2. I put the problem at difficulty level 2. So before I proceed with the calculation, let me draw a simple figure to illustrate a head-on or one-dimensional collision and explain the terms appearing in the question. So suppose this is a horizontal smooth surface on which there are two particles in motion. This is particle 1 shown in blue color, and ahead of it this particle in red color is particle 2, and the motion to the right is taken to be positive according to my sign convention. This is particle 1, this is particle 2. Since they are spherical, I might refer to them as balls also sometime. If particle 1 has to catch up with particle 2 and collide, it only means the initial velocity of 1 should be greater than the initial velocity of 2 before the collision. So I call the velocities as u1 and u2 respectively, according to my question here. And after a time, this particle 1 catches up with particle 2, which means particle 1 is pushing into particle 2 from behind, and at the instant of maximum deformation, you have learned the velocities acquired by both the particles will be the same. Let me call that velocity, is common to both of them at the time of maximum deformation, to be v0. And during the brief period of contact between these two particles, that is called collision here. So let me show here also the impulse given by either particle on the other. I'm using green arrows for that. This arrow is standing for the impulse imparted on particle 2 by particle 1, and I'm calling it the vector I directed to the right. Similarly, on particle 1 also to exert an impulse in the leftward direction of same magnitude, therefore I'll be calling it minus I according to the vector notation, right? And later, after the collision is over, particle 2 is moving forward with a greater velocity, which I'm calling it v2 now, and particle 1 is following it with a reduced velocity that will be calling v1. So I call these velocities as v1 and v2 respectively. That's my assumption, and they have given in the question the masses of the particles are m1 and m2. e1 and e2 also are given, but v1, v2 I have taken it myself, so I have to get rid of them while reporting the final answer. And remember, this is a partly elastic collision mentioned, for which restitution coefficient, the value of E is less than 1. That is just any value between 0 and 1.
Hello students, you got a glimpse of our video lessons through this small lecture. We have hundreds of lectures like this one covering various topics of advanced school level and intermediate physics in our website. They are exhaustive and often accompanied by elaborate diagrams to make concepts even clearer. They are taught with passion and sometimes with a bit of fun. So, at the end of the lesson, you have a commanding grip on the subject and you are ready for the board and competitive exams. Subscribe at physicsacademyonline.com to access video lectures of highest standard on various topics of physics.